All right, we are about to pull back the curtain on something pretty wild, the mind of an AI. There's this new tool called Neuronpedia, and it promises to let us actually look inside the machine. And you know, this might just change our entire relationship with artificial intelligence. Let's see how.
So, we ask AI to do all sorts of things, right? Write stuff for us, code, create art. But how does it really do it? I mean, what is actually happening inside those incredibly complex neural networks when it decides one word should follow another? Honestly, that's one of the biggest questions in technology right now.
And the reality is, for most of us, and this includes a lot of the developers who are actually building these systems, that internal process is a total mystery. We see the input, we see the output, but everything in between is just a complete black box.
Okay, so let's take a closer look inside this AI black box. And this isn't just, a technical curiosity. As these models get woven into basically everything, our search engines, our cars, you name it, not understanding how they think becomes a really serious safety and control issue.
And this quote just hits the nail on the head. It perfectly illustrates the disconnect. We use these biological terms like neurons to describe how the models work, but really, that's just an analogy. We haven't had a way to actually peek inside and see what a specific neuron or feature is responsible for until now. So, how in the world do you map a mind that isn't biological? Well, you build a Wikipedia of neurons, and that brings us to the tool that's at the heart of our explainer today, Neuronpedia. Think of it as a collaborative atlas for the AI brain. Now, the core idea here is just so cool. The creators literally call it the Wikipedia of neurons for large language models. And it's such a powerful metaphor, right? It just perfectly captures the goal to create a shared, navigable resource for understanding AI from the inside out. So, to get a little more formal, Neuronpedia is an open-source platform built for researchers and developers. Its mission is to speed up our white box understanding of these networks. In other words, to help us move away from seeing them as these mysterious black boxes and start seeing them as transparent glass boxes, where we can not only observe, but actually interact with the gears inside.
Yeah, just think of it like a public atlas. It maps out all the internal components, the neurons and the features they represent for real, powerful models that are out there right now, like Google's Gemma and Meta's Llama. It's a shared resource for the entire community to use and build on.
So what does it actually mean to have an atlas of an AI's mind? Well, it really comes down to three incredibly powerful things you can do. You can explore, you can search, and you can even steer the AI's thoughts. Let's break down what each of those really means.
And get this, the scale we're talking about is just staggering. It's a searchable database of over 50 million distinct features or internal concepts that the AI has learned on its own. It's like a massive, massive library of the AI's mind.
So here's how it works in 3 basic steps. First, you can explore the raw data, and we're talking over 4 terabytes of neuron activations, which is basically a record of when each part of the AI's brain lights up. Second, you can search for specific concepts. And third, and this is the real game changer, you can steer the model's behavior by directly tweaking those activations.
So what kind of concepts are we talking about here? Well, it could be anything. Researchers have found features that correspond to a legal tone in writing, or to a very specific concept like the Eiffel Tower. And, really crucially, they've also found features for sensitive concepts like self-harm, which has absolutely huge implications for AI safety. This ability to pinpoint and then manipulate these specific features, it's a huge leap beyond how we currently try to control AI models. This is what moves us from basically just guessing to doing some true engineering. Okay, so here's the crucial difference. The old way, what we call prompt engineering, is like giving someone vague directions and just hoping for the best. Feature steering, the new way that Neuronpedia makes possible, is like having a detailed map and surgically intervening to guide the model's output with incredible precision, and that drastically reduces all those unwanted side effects. And that's the ultimate goal here, Neuronpedia isn't just some academic tool for understanding what's going on. It's about building a bridge from that understanding to tangible, real-world control over AI behavior. It's all about making these systems safer and a whole lot more reliable. And for the teams who are actually building with AI, the benefits are immediate. It cuts down experimentation time like crazy. It lets you justify your interventions to regulators with cold, hard data by pointing to a specific feature you modified. You can finally move beyond that feeling of, well, it seems to work, to a place of documented, defensible engineering. So where is all of this heading?
What does this mean for the future of AI? Well, this isn't just a new tool. This is a sign of a fundamental shift towards a future of transparent AI, a future where we finally understand the technology we're all building.
I really think we are at an inflection point. The era of treating AI like it's some kind of inscrutable black box magic, that's ending. With tools like Neuropedia, we're stepping into a new era where we can understand these systems with scientific clarity and engineering precision.
And this all brings us to one final, pretty profound question. For the first time, we're developing the ability to genuinely read an AI's internal concepts. As that ability gets better and better, the challenge is no longer just about what we can get it to do, but about what we believe it should know. So if we can read its mind, what should we be teaching it?